Hello and welcome to Math 164 Pre-Calculus 2. I'm Jim Atkinson. I'll be your instructor this second summer term. And for our first class, we're going to have a video lecture. I hope that you'll find this to be useful. You should have printed out a copy of the notes that we'll be looking at in the video here. So make sure that you have that printed out and in front of you, and you can fill those notes in as we go through the lecture. We'll be beginning with Chapter 5, Trigonometric Functions. We'll be spending the majority of the term talking about trigonometry, so that's the big topic in this course. It's not the only topic, but it's the main topic. So we'll begin Chapter 5, and we'll do Section 5.1. We'll continue with Section 5.2 when we have our class on Monday of next week. So Section 5.1 deals with angles and their measure. So first of all, let's just talk about some of the basics of angles. When we define the trigonometric functions, we define them as functions of angles. So before we can study these functions, we need to know something about angles and their measure. In trigonometry, we define an angle as a rotation, clockwise or counterclockwise, of a ray about its endpoint. An angle theta, so that's the Greek letter theta that you see there. We typically use Greek letters to represent angles in trigonometry. An angle theta with positive measure is shown at right. So an angle with positive measure is generated from a counterclockwise rotation of a ray about its endpoint. The beginning position of the ray is called the initial side of the angle. The final position of the ray after the rotation is called the terminal side of the angle, and the endpoint of the ray that is basically the pivot for the rotation is called the vertex. A positive angle measure corresponds to a counterclockwise rotation, as is illustrated in the figure to the right. A negative angle measure corresponds to a clockwise rotation. So counterclockwise is positive, clockwise is negative. The next thing we'll need to do to associate angles with values of the trigonometric functions, and we'll define the trigonometric functions starting in Section 5.2, is to place our angles within a coordinate system. So this allows us to associate the angle with points in the xy plane, and this is actually how we define the trigonometric functions of any angle. An angle is in standard position if its vertex is at the origin and its initial side lies on the positive x-axis. So an angle in standard position would have its vertex at the origin. So that would be our vertex. And the initial side would be coinciding with the positive x-axis. Sorry about the pop-ups. Sometimes I touch something with my hand. I'm using a tablet here, and something pops up that I don't want to pop up. So you may see that from time to time. I'll try to keep it to a minimum if I can. So you have your initial side, you have your vertex at the origin, and then you have an angle. So you kind of sweep that ray through the xy plane, and let's say it kind of ends up here. Okay, so that would be the terminal side of our angle, and let's say that we generated this through with a counterclockwise rotation, as shown like so. And so let's call this angle theta. This might represent an angle of 135 degrees. Notice that the terminal side of the angle ends up in quadrant 2, so we would call this a quadrant 2 angle. Notice that this angle here is 45 degrees. So if we went around half a revolution, that would be 180 degrees, as of course we're familiar with. So this is what we would call a quadrant 2 angle. Another example would be we might have a clockwise rotation. Maybe, say, the angle, the terminal side ends up here, and we have the ray swept out in a clockwise direction, and perhaps this is theta equals negative 60 degrees. Notice the terminal side of the angle ends up in quadrant 4 in the XY plane, so we'd call this a quadrant 4 angle. So notice that with the clockwise rotation of the angle, we give the angle a negative degree measure. All right, and then for a third example, let's illustrate what's called a quadrantal angle. The definition is just above there. If the terminal side of our angle lies on one of the axes themselves, the angle is said to be quadrantal. So for example, let's say that we have an angle that goes through one complete revolution and then a fourth of another revolution. Let's say it's like that. So you see it's still starting from the positive x-axis. And if you think about this, you know that one complete revolution is 360 degrees, and then we're going 90 degrees beyond that, so 360 plus 90 is 450. So this would be a 450 degree angle. So this would be what we call a quadrantal angle. And so you can see that you have all kinds of possibilities when it comes to angles. Since angles are rotations, we don't necessarily think of angles in the sense of a corner of a triangle or something like that. You can have angles of measure greater than 180 degrees, greater than 360 degrees. You can have positive measure, negative measure. So you have all of these different possibilities, really just an infinite number of possibilities when it comes to angle measure. So this is an example of a quadrantal angle, 450 degree angle whose terminal side coincides with the positive y-axis. Well, we've obviously already been talking a little bit about degree measure, since just about everyone is familiar with degree measure. But let's look at degree measure in a little bit more detail. In the examples above, we are of course using degree measure. To be precise, we define 1 degree to be the angle formed by rotating a ray counterclockwise 1/360th of a complete revolution about its endpoint. Thus, an angle formed from a complete revolution has measure 360 degrees. You should review the definitions of acute, right, obtuse, straight, complementary, and supplementary angles in relation to their degree measures, and you can find that information on the bottom of page 472 and the middle of page 477. I will just very quickly review these definitions without writing anything down, and we don't see the definitions in the notes, but you can look at them in the book if you need to. An acute angle would have a measure between 0 and 90 degrees, less than 90 degrees. A right angle would be 90 degrees, of course. An obtuse angle would have a measure between 90 and 180 degrees. A straight angle would be an angle of measure 180. Complementary angles are 2 angles whose angle sum is 90 degrees. And supplementary angles are two angles whose angle sum is 180 degrees. Traditionally, degrees were subdivided into minutes and seconds, where 1 degree equals 60 minutes. So that little mark is read as minutes, 60 minutes. And 1 minute was further subdivided into 60 seconds. So 60 seconds in a minute, 60 minutes in a degree. This is often referred to by the abbreviation DMS, which stands for degree, minute, second measure. Today, it's more common to subdivide degrees into decimal parts. This is called DD, that is decimal degree notation. And throughout the unit on trigonometry, we will usually, if we're working in degrees, use the DD notation, but occasionally we may see also the DMS notation, and you need to be at least familiar with the DMS measure of an angle in case you see it. You sometimes will see it in applications, for example, in applications that might involve something like surveying, something of that nature, where that kind of measure may still be used. So we will do some examples where we make use of the DMS notation. But the DD notation, that is the decimal notation, will be more what we'll typically use. Now, a second type of angle measure, which most students are less familiar with, but which actually is the more important measure, especially as you go into more advanced mathematics such as calculus, is radian measure. And the reason radian measure is of greater importance than degree measure is that there is a correspondence between angles measured in radians and real numbers. And what this allows us to do then is to define the trigonometric functions as functions not only of angles but of real numbers. And it's radian measure that allows us to do that. So let's gain a little bit of familiarity with radian measure as well. So the figure to the right here shows how we would define an angle of 1 radian. We define 1 radian to be the measure of the central angle of a circle of radius r that intercepts an arc of length r, as shown at right. So the central angle is an angle whose vertex is the center of the circle and whose initial and terminal sides correspond to radii of the extended radii of the circle. The intercepted arc is the arc of the circle that corresponds to the central angle, and you can see that the length of the arc here is identical to the radius of the circle. When the intercepted arc has a measure exactly the same, let me start over. For a central angle, when the intercepted arc has the same length as the radius of the circle, then the central angle will have, by definition, a measure of 1 radian, exactly 1 radian. In general, if a central angle theta intercepts an arc of length s, so where the arc length might be some value other than the radius itself, then the radian measure of the angle is s over r radians. Because we are dividing arc length by the length of the radius, and we would be measuring arc length and the radius in the same units, it actually turns out that radian measure is unitless, dimensionless in other words. So we don't even have to use radians to describe it. We can just describe it as a real number. And this is again corresponding to the fact that we can relate angles measured in radians to real numbers. We'll continue with where we're leaving off here in the next video. I only have 15 minutes per video, so we'll continue with the next video from this point.